What's up everyone, Nader here. In this video, what I'd like to do is go over browser events, but specifically event bubbling and event delegation. As a byproduct of this, we're also going to go over event capturing, which is the first part of the bubbling process. This is actually a really important topic. I really wanted to separate this out into a separate video, apart from the introduction to events, which is what we went through in the previous video. This is really central to understanding general kind of event behaviors, even across different frameworks like React and others once we go beyond kind of vanilla JavaScript. The bubbling process and even something called event delegation, which we're going to get into in this video, is really a way for us to make it more efficient and easier to think about these events and how they work in the browser, and also debug them together so that when we see different issues pop up as we're working with different types of events, since everything really is quite event driven in JavaScript, it's much easier for us to conceptualize what's actually happening so we can actually focus on debugging the actual issues. So without further ado, let's actually get right to it and see what we can do. Okay, so to start, I just want to kind of go over holistically browser events again. We saw in the previous video a little bit about this, so take a look at that if this is your first introduction to how events work in JavaScript in the browser. In this video, as I mentioned, we're going to go over capturing, bubbling, and event delegation. These are all words used specifically in the context of browser events in JavaScript, and these all kind of work together to actually make it easier to actually work with these events through different systems in the actual language. So actually, let's see how this works, starting with the capturing process so we can actually visualize this a little bit better before we get into some examples. So over here, I have a slide that demonstrates the event capturing process. So let's think back to kind of how events work really quick, just so we can kind of lay the groundwork. Events in JavaScript are a way for different elements on the screen to actually tell other parts of the DOM that something happened. Right, so we looked at kind of the signal fire example as kind of a theoretical model to kind of picture how this would work in the real world, right? As an analogy. If I light a signal fire that's blue, maybe that is signaling to someone else that can see that signal that something happened, and it might be different from something when it's green or when it's red or something like that. So the same thing is true in JavaScript. We can attach events, and these events can fire off kind of like a fire or a signal, and that event can be listened to or watched by the JavaScript engine and many other parts of the DOM as well. So in this case, what we're going to look at is the first part of that process. Well, really the first part is actually firing off the event. So we'll assume the event actually got fired. So let's talk about what that actually means in the context of this example I have on the screen. So you can see right here on the left-hand side that I actually have a little bit of HTML with some JavaScript kind of sprinkled in. So this is just a basic web page with a button that says click me on it. And when we click on this button, we have an on-click event being registered that calls the capture function, which we define down here in the actual script section right here. We see function capture, and it's just going to log boo to the screen. So this blue part is really what's that I have highlighted is what's kind of the actual source of this event. So when we actually click on this button, it's this button element that's kind of generating this signal fire, if you may. Okay, so let's look at what happens in the actual behind the scenes when we actually click this button. So when we click on this button right here that says click me, the event fires and calls this capture function. Okay, so what happens when this event actually fires? There are three kind of main stages that happen, which is kind of what I was hinting at the previous slide. We're going to start by looking at the capturing phase, which is the first phase that occurs when an event fires in the DOM in JavaScript. And that starts at the very, very root of the DOM, in this case at the window element. So we start at the window, and the event kind of travels down the DOM throughout this DOM tree to reach the actual target. In this case, the target is the button that we clicked on. So that sounds kind of weird, right? Because I kind of just mentioned earlier that, hey, we click on the button generates the event, and we kind of fire it off. Right? So in kind of conceptually, you probably are thinking, well, shouldn't the button kind of be the one where the actual event gets generated, I guess, and like kind of gets fired off, and we start there and kind of move elsewhere from there? Well, actually what happens is all events actually start at the root. And this is kind of where the mental modeling becomes really important, so you can understand these different phases and help us understand bubbling and capturing and delegation much better as well. So To clear things up, all events in JavaScript in the DOM are going to start at the root, no matter where they actually are targeted. Okay, so why is this? Well, we can actually do different things along the way in this DOM structure to events as they travel through this tree. That was a tongue twister. In this case, we are trying to basically reach this button element, but we're going to start at the root. So we're going to start at window, which is the kind of global object in the context of the DOM in the browser. And we're going to move to document, then we're going to move to HTML, which is out here. We saw a bit of this kind of in the DOM structure in previous videos. Then inside of the HTML, to get to the button, we actually need to go into the body, which is right here. So that's what we see next. And then the button is finally located inside of this div right here. So in this div is that button, which is the final target of this actual event that was generated. So we're actually traveling through from the root down to the actual target, in this case, which is the button that we want to actually generate the event. So this phase is called the event capturing phase. Okay, now we're going to look at this in more detail in the exercises and probably a little bit in the example later, but this is really central to understanding the next phase, which is actually the bubbling phase. You probably have heard bubbling a lot more than you've heard the capturing phase, but it's important to realize that bubbling is actually technically the third step in this process. We start by generating the event. Once it's generated, we go through these three phases, which I'll actually show you later on in the actual codes that get generated by this event. The first phase is the capture phase. It starts at the root. It travels all the way down, which is what I'm demonstrating right here. And then we reach the target phase, which is once we actually hit the actual button itself, in this case, where the event was generated. Now, what most people refer to is this next phase, which is what I'm going to demonstrate right here in the next slide. Once we've reached the target, which I've denoted as step 2 here, which I just mentioned, we actually reverse this process and we go back up the tree. Okay, and that's where the term kind of bubbling comes from, right? Bubbles kind of move upwards in the water. It'd be kind of strange if the bubble kind of moved downwards in the water. So we have capturing, and then we have the target phase, and then we have the bubbling phase. Okay, so once we have reached the target, in this case, the button, the event bubbles back through the DOM up to the window element again in the browser. So here we go from the button up to the div, just a reverse process up to body, HTML document, and then finally we end at the window. Okay, so we start by capturing, then we hit the target, then we bubble up. Colloquially, what people generally refer to this entire process as is kind of event bubbling. However, technically speaking, there are these three distinct phases, and bubbling is actually the latter half of this phase. And we can actually see these phases as denoted in JavaScript by explicit quotes. Okay, so let's kind of take a look at kind of how this works. I'm actually just going to kind of cheat a little bit. I'm going to kind of copy this over here so you don't have to watch me really type it out, and I'll quickly go over it in the VS Code. But I'm going to switch over to VS Code. I'm going to make a new file over here, and I'll just call this a bubbling.js. Sorry, .html, not .js. I get too used to making these JavaScript files. And I'm going to paste that in here. I hope I had that formatted correctly. I'll give that a quick save, and I'll zoom in a little bit more so you all can see that a little bit better. And let me just go through this really quick, and you can type it out. Normally I would type this out manually, but just to speed this up a little bit, since most of this is repetitive, I'll kind of just go over really quick what's actually happening here. So I have the HTML tag out here. I have a head tag with a title with bubbling in there. And then the body tag is here where all the magic's happening. We have our div tag, which contains our button. Our button has an attribute called onClick, which calls the bubble function immediately as soon as it's clicked, and it's labeled as click me inside the button. And then we have a script tag at the end again of our body, so it actually gets run last so that we can actually do things in here related to the DOM if we need to after the DOM is loaded fully. So in here we have our bubble function, and it's just going to simply console log out boot. Okay, so let's just see how this works, just so this makes sense, and we'll kind of go through a couple of interesting things behind the scenes. So I'm going to open this in my Finder here. Let me just zoom in a little bit. I'm going to double click it to open it in my Chrome browser. I'm going to zoom in as well over here. And there's my gigantic click me button. I'm going to open up my console. And I'll zoom in on this a little bit as well, just so that we can see that. And what we'll see is in this kind of DOM structure here in the Elements tab, we have kind of everything that we would expect to see, which is exactly what we just saw in the VS Code HTML code together, right? We have kind of our onClick function here, and then the script with the kind of inline bubble function inside the script tag directly. Okay, so if I switch to the console tab, and I click this button, let's see if we get what we expect. So there we go, we get boo logged out, right? I click it a whole bunch of times and we get a whole bunch of boos, right? You can see the number ramping up there. So that is exactly what we would expect to happen, right? So what did we do? We attached the onClick event, or the click event handler, to this button using the actual attribute, which can only attach one in this case, or we could have done an add event listener as an alternative option, which we saw in the previous video, and we attached this bubble function. Okay, so the next thing I'd like to show off is actually where things get really cool, and then we can start going a little bit deeper and seeing a little bit more about this entire capturing process. I do want to save a little bit of that for the actual exercises so that you have a bit of challenge and I don't give you all the answers right away, but let's just take a look together to see kind of how this all comes together with what I was hinting at before, which is called event delegation. So this part, which I'm about to show you, is actually very central to understanding kind of everything about the event process, including capturing and bubbling, and how we can really take advantage of this process specifically, which is capturing and bubbling, to make more efficient web programs. Okay, so let me show you what I mean. So over here, I have a slide that kind of shows off a bunch of HTML on the left, and I'm going to show you this idea of event delegation using this HTML. So let's take a look at the HTML real quick. We have a whole bunch of HTML here. You can see that the script just ends down here, but I'll scroll back up so that we can actually kind of look at the meat of this part here. We have a head here with a title. Now we have a body. And in that body, I have a unordered list with 3 list items inside, home, blog, and about, which is highlighted here in orange. And then I have a script directly below that so that I can actually target the actual DOM above it with query selector, for example, in this case. So the DOM is actually loaded beforehand before the script actually runs. So what is this script doing? Well, let's take a look line by line. Over here, I have a document query selector all. I'm grabbing all the list items in this. So I'm going to get an array of DOM elements that are all li tags. In this case, these 3, right? The 3 li's here. And I'm going to say for each of those, using a for each loop, you can also use a for of loop. For each of these nav items, I want to actually add an event listener, which is the click event listener, and I want to log this kind of, whatever this function is, e.target.text content. Okay, so there's kind of a lot going on here in a very small amount of code. So let's kind of go through this part a bit kind of more carefully in VS Code together. So I'm actually going to copy this as well. Again, apologies for copying. I just wanted to speed this up a little bit, and I'll go through it again in VS Code. I'll switch over here and create a new file in VS Code. I'll call it delegation.html. I'll paste it in and I'll save it, and I'll kind of go through this in here. I think I have a mistake in here somewhere. Probably a missing bracket, I'm assuming. Probably right here is what I'm guessing. There we go. And then that will close that off. So let's take a look at this HTML together. So we have the head with a title. We have our body with our 3 li's inside of a UL tag. And then we have our script. And what is our script doing? Well, it's grabbing those 3 li's. We're looping through each of those li's, which is what nav is going to be. And we're adding an event listener to each of these here, right? One at a time, 1, 2, 3. And what are we doing with that event listener? We're adding a click event listener, where it's going to call a function, this function right here, when that li is clicked. And that function is going to be passed automatically by JavaScript, the event, and as an argument, and we can actually log out things using that event if we want, or do other stuff. In this case, we're logging out e.target.text content. So really quick, before we actually see this in the browser, I'd like you to think about this. What word stands out to you in this line right here on my screen on line 15? e.target.text content. So I would say that e.target definitely stands out, right? If we kind of go back to my drawing here in the bubbling process, we can see that target probably means this, right? The actual target that fired off the event that the capture process brought down to our target and then bubbles back up from the target, right? So in the context of this code right here, if these are being attached to each li item, we can probably say that each of these targets is each li item. And if we're grabbing the text content, it's probably going to be the text content inside of that tag, which is going to be either home, blog, or about in this case. So let's see if that's true. I'm going to show this in Finder, and I'm going to double click it to open it up in Chrome. I'll log in a whole bunch, or zoom in, sorry, a whole bunch here. I'll open my inspector. And let's just make sure this actually looks as we expect it to. So here we have our script. Here we have each of our LIs. Our LIs each have a whole bunch of CSS to them as well with the markers and stuff. But we can see that all there. And then here's our script right here at the very, very bottom. So that's pretty cool. So that works quite nicely. Let's go to our console here. So what we expect is when I click on this LI, right, I want to see the text content, right? So home, blog, about. Blog, home, blog, home, right? So that works quite well. So the target here in this case is the actual LI. So if I kind of bring over my mouse here, we can see that each of these LIs is actually spanning this entire width, in this case, of our browser, right? That at least I have open with the console on the side. And if I kind of move my mouse kind of over here, we have the rest of the body. Over here, you can see that this is the part of the UL over here. So the blue parts are the parts that the event listener is really attached to, because that's the LI tags. Everything else is outside of that LI tag. So let's see what happens if we click outside of there. Let's say I click down here. I'm gonna click down here. Notice that nothing really happens, right? There's no events being logged over here. Maybe if I click over here to the left, nothing happens either, right? Which kind of makes sense because that's where our UL is. That's not where the LI actually is. In fact, funnily enough, with the way that LIs are structured in the DOM, even if I click, actually, I guess in this case, the markers are actually counted as part of the LI. So that's actually good. That actually works quite well. It's just separated as a separate kind of pseudo element in this case. But if I click to the left over here, that's the UL itself. Down here is the actual body, but the LIs over here, you can notice even if I click to the right, we saw that it spans all the way across, that actually logs out as we expect. Okay. So what is all this about, right? We kind of know how events work, and this is nothing really too special. We saw this is just a regular click event. I guess we're getting a little bit fancy. We're adding it kind of in a script here. We're going through each of these, and we're adding it dynamically. We're adding one click event listener, in this case, for each of these LIs. And we can kind of confirm that if I go back to Chrome and I go back to the Elements tab and I look at the event listeners, we can see that in this LI right here, if I kind of make these a bit smaller, I have a click listener right here, I have a click listener right here, and a click listener right here, right? So each of these has a click listener on them. So that's on the event listeners tab at the bottom. If besides styles, computed, and layout, at least in Chrome, it might be slightly different in the other browsers. So going back to our slides, like why is this important? And like how is this related to delegation? So you might notice that with this example, we have 3 LIs, okay? And what we needed to do in order to detect clicks is the most logical thing is just attach an event listener, right, to each of these LIs, because that's what we want to detect. We want to detect when you click on home or click on a blog or click on about, and then we want to do something about it. But imagine if we had 10 of these, or then if we had a sidebar with another 10 links, and then maybe there's like a sub nav bar, and that has like a whole bunch of fans out and a whole bunch more links, right? Do we really want to be adding like a dozen or even maybe 100 event listeners just to detect all these clicks? These event listeners are actually quite intensive resource-wise. JavaScript and the browser has to keep track of all these different events firing in different places, and then every time we click somewhere, even if we don't do anything with it, the event still has to fire through this entire bubbling process. So the question is, well, is there a better way? Right? Imagine, let's just for even just theoretical, just conceptually, imagine that there's like 100 things that we need to monitor inside this UL or inside a div or inside something, right? And we don't want to add 100 event listeners, right? How do we more effectively and more efficiently manage these event listeners, but irrespective of the amount of kind of children or things that we need to deal with inside of there. Well, that is where this whole idea of event delegation comes in. I want you to think about this word delegation because this will help you remember this concept much easier. Delegation, it comes from the word delegate. So delegate generally in the context of kind of the human realm means that I'm going to kind of delegate a task or delegate something to someone else or something else so that thing or that person can do that. So maybe I delegate, my calendar management schedule to like a little AI calendar robot thing, and it will kind of help manage my calendar for me, right? I actually do this kind of on a daily basis. I delegate kind of my memory to my phone or to my calendar so that it can remind me of tasks in the future that I have planned that I actually don't really want to remember. I probably would forget unless I had that task like photographic memory or something, which I definitely don't have. So I delegate kind of a bit of my memory to different devices, and those devices are responsible to let me know when that happens. So how is that related to this concept of the DOM and event delegation? Well, what we can do is we can delegate the task of managing these events to kind of a higher power, a higher DOM node in this tree that can be responsible for managing all this kind of complexity and event task management for all of its kind of underlings in this case, or all of the kind of children nodes in that element. So let me show you what I mean by this. If I switch back to this next tab here, I've actually taken that exact example and changed one small thing to fix our entire problem and introduce us to this concept of event delegation. So check it out. This code is almost the exact same. We still have our UL tag with our 3 LIs inside of it. The only real change is where we're attaching this event listener. Previously, we were attaching one event listener for each of these LIs, which is why we were going through query selector all for the LI and then attaching a click event. Over here, what we're going to do is we notice that the kind of common ancestor for these 3 LIs that we can probably think of as a delegation target or responsible for the 3 children LIs and under it is really this UL, right? That's kind of the purpose of a UL. This unordered list is, of course, going to have one or more list items inside of it because that's kind of the point of these lists in the DOM. So what are we saying here? Well, we're saying, okay, well, if we can say that the UL is responsible for the LIs, maybe we can do this instead. Maybe we can grab that UL instead of grabbing all 3 LIs or more, and we can add the event listener to that UL. Okay, so what does that do? Well, is that going to kind of break our code? Well, let's take a look what's happening here. We're adding a click event, same as before, and we're just logging e.target.text content. Okay, I want you to think about this for a second. If I ask you this question, what would be your answer? If I have a click event on this unordered list, but I click on the list item inside of that UL. So for example, if I click on home, right? But the actual event is attached to the UL, but I click on the LI inside the UL, what is JavaScript going to think the e.target or the target of that event is going to be? Is it going to be the LI or is it going to be the UL? So think about that for a second, because that's just key to understanding the delegation. All right, so I'm going to slowly build up to this. I'm going to kind of copy this over. I'm going to make another file here in VS Code. I'm going to create a new file. I'll just call this delegation2, delegation2.html. I'll paste it in. Let me kind of go through this code really fast, just so we're all on the same page. We have our head with our title, our body, all the UL in it, and then here's our script grabbing just the UL in this case, which is one event listener, because there's only one UL in our entire DOM in this case, and we're attaching a single click event that logs out e.target.text content. Okay, so I'm going to open this in my Finder. Open delegation 2, do my whole little zoom in thing here, open the console, and let's see what happens. So what was your answer? And let's see if that's actually correct. So I'm going to click on home. We see home. Interesting. I'm going to click on blog, click on about, click out here. Interesting. Okay, so I want you to think, is this what you expected? Right? So what is actually happening here? Let me show you what's actually happening behind the scenes. I'm going to go back to VS Code, and I'm also going to log out right here inside of this event listener, e.target, just so that we can actually see what that is, as well as the actual text content. I'm going to switch back to Chrome, reload the page so that all my console disappears. And I want you to take a look at this. When I click on this li right here, this home li, what is going to be the target? Okay, so it's going to be the li. That's the target, right? That's why we see the text content, which is inside here, as being home. Same is true for this one and this one. They're just different LIs, and each has their own different text content. What if I click over here, which if we see the inspector again, notice that this green section, or I believe actually maybe the entire orange section and the green section are part of the UL over here. So what happens if I click over there? Well, look at that. The target is no longer the LI. The target is actually the UL, right? Because I didn't click on the LI. I clicked on the UL in this case, right? Well, what happens if I click over here in the body? Well, nothing happens. Well, that actually checks out, right? If we look at this UL, what does text content actually do? It actually strings together all of the actual text content inside of these different nodes. It strings them all together from all the children and kind of dumps them to the screen. So in this case of the LI, we can see a bunch of spacing, as well as all the text from each of the children LIs inside of that UL, which is why we see this kind of formatted view of all these different links when we actually click the UL, which is a target, which is all of these text nodes, the text content from these LI nodes being logged out. But if I click on the body, nothing happens because we don't have a click event listener there. But if I click on each LI, we actually get just that target's text content printed out, as well as the target itself. So what is this kind of doing for us? Well, if you think about this, what this allows us to do is decide one place per set of things that are related to work with and attach event listeners to, so that we don't have to go through and attach hundreds or dozens of different event listeners and deal with all of them separately and add resource constraints to our different application. Apps these days are getting quite complicated on the web, and the more of these that we add all over the place, the more slow our app actually gets and complicated to debug it gets as well. It's much easier to deal with these exactly at the level that we need them, which in the case of most event delegation is going to be the closest common ancestor to the things that you're trying to monitor for that event. So we actually went down in this particular example from having three event listeners, one for each of these LI nodes, to the exact same behavior, but for one. The only change is now the only difference, I guess, is if we click on the UL, there's actually a click event being registered. So that's a little bit challenging to deal with, but we can actually use the tag names to actually deal with that and filter that out if we need to. We can actually tell exactly where the event originated from and the target is, and we can actually use that tag name to determine if we want to actually use that in our logic or not. So we saw that in previous videos with tag names and the different node types as well. So to sum it all up, effectively what we did was we actually reduced the amount of work and load on our application by using event delegation so that we can have one node responsible for all the nodes below it for a particular event type. And this can scale to all different types of events, as well as all different types of nodes all across the application. And we can reduce the amount of listeners we have across the app significantly and make our logic much cleaner and easier to debug and understand for both ourselves and other developers in the future as well. This is a very powerful technique and tool that I don't actually see used enough, and will become very handy for us now that we know how it works to actually see in use across even other scenarios like things like React. Now, I do want to point out a couple of small things and show you a quick demo of this as well before we go to the next video, which is the exercises. There are some other methods on the event object here that become very useful depending on the situation you need. I'm not going to go through them in depth because some of them are pretty specific to different use cases, which we'll actually see better through actual examples, for example, in the exercises. But there are things like we can stop this propagation of the actual events. So what does that mean? Well, now that we know that there's these three phases, we can actually attach events in this phase or in this phase. By default, events are actually attached in the event bubbling phase, right? So we are listened to in the bubbling phase. We actually have to add something separate in the event listener to actually have it be captured in the captured phase instead, or be listened to in the capture phase instead. But by default, everything is done in the bubbling phase, which is also another reason why people call this event bubbling. But we can actually stop, for example, the propagation over here or over here, so it never actually reaches over here or never even actually reaches the target. And we will see that in the exercises later. We can prevent the default behavior of events, which is very common with things like forms and different types of buttons and other things like that, so that we don't cause reloads of the page or unintended behaviors with the default behavior of different DOM elements. And then there's this thing called composedPath, which I want to show you really quick to wrap up this video because I find it very useful to actually visualize and conceptualize a bit of what's actually happening here behind the scenes. So if I switch back here, I'm going to do e.composedPath, and this is a function just like that. And this is on the event object itself. So I'm going to, instead of logging the target, log e.composedPath just so you can see kind of the path of this actual event through the DOM. I'm going to switch back to my Chrome here, reload the page. I'm going to click on this LI, which is the home. And what you'll see is this list here of all the DOM nodes of the actual path of the event. And in this case, it's in the bubbling section of the path. So where the target is the LI, then we move out to the UL, then to the body, then to the HTML, then to the document, then to window. Okay, and in the capturing phase, it would be the opposite. Although I believe composedPath only shows this kind of list like this. It doesn't actually show the reverse. But this is very important to actually see and prove to ourselves that the event actually is coming directly from the window, and the path of this event traverses through its entire DOM tree depending on where the actual target is. So if I click on the actual UL out here, you can see that the path of this is slightly different because it doesn't go all the way down to the target, which I clicked, which is in the previous example, the LI. I clicked in this case, the UL, which is one step above it. So the event doesn't need to travel all the way down to the LI. It just stops at the UL and then bubbles back up. Okay, so hopefully that was a useful video for you. There was a lot to unpack there and it was quite dense, but just to kind of recap all that for you, the most important things to kind of keep in mind are these three different phases from the event process. We have capturing, the actual targeting phase, and the bubbling as well. And then we have delegation, which is this technique that allows us to really remove the amount of listeners that we need and actually the amount of complexity in our app, so we can actually abstract away a little bit of the event management process to fewer nodes in our tree. And then we can use some of these other specialty methods as well, along with this entire process of delegation and event bubbling and capturing to actually do a lot with our application. We'll see more examples of this in the exercises for this particular topic. So hope you enjoyed the video. If you did, I would love it if you could like the video and subscribe to the channel. I'd love to hear also what you think of this in the comments. If you have used this technique before or similar techniques, or if this helped you understand bubbling in general, I'd really appreciate kind of your ideas in the comments and kind of how you thought this video went. In the next video, what we're going to do together is go over a bunch of exercises to actually get hands-on with this process and get a bit of complexity here and actually use some of these examples here to really get a better understanding of how both event bubbling, capturing, and delegation all work together to make our apps work in the browser together. I will see you in that video. See you later.